Okay, good morning, class. So today we're looking at the functions. We're reverting back to the textbook, our textbook we are using. So yesterday in our previous lesson, we looked at determining the equation of parabolas, straight lines, exponential graphs, and hyperbola graphs. Not so. So those four graphs we have determined already. Okay, so now we're just going back to the textbook so that we can carry on with interpretation of graphs itself. Okay, so in the part one, we looked at situations where you are determined to draw the graph. So we have dealt with interpretation already. We looked at domain, we looked at range, we looked at where the function f of x is equal to 0, we looked at functional notation, we looked at if f of x is less than 0, we looked at axis of symmetry. No, not so? And those things. So anything I left out? Increasing and decreasing. Now they can ask you that, and at times they could give you the graph and could ask you questions around that as well. Okay. So let's look at the example here. So now we're going to look at our textbook again, which is the Clever Maths. Not Clever, that's grade 11. Classroom Maths. Clever Maths is grade 11 textbook we use. So the question says determine the equation of the graph. We must be given one piece of information for each unknown. Okay, so there's two unknowns, you need two pieces of information. Three unknowns, three pieces, and so on. You guys understand? Because Lisa Kanya is getting a lunch from me now. I'm glad Lisa Kanya, where's my help? Oh, now you're putting it away. Okay, nice. You don't want to give me any. Okay. But anyway, so let's look at the example. The example's on page 171. We're looking at the examples for exercise 108.4. Now you're going to find 8.4 to be very simple. Why? Because we have done all these graphs already. Okay? But as more revision for you guys, your homework will be exercise 8.4. Okay? You're just going to do a run again through all of those examples. And if you have a problem, you just let me know tomorrow. Okay? So the question says, determine the value of a and q in the parabola y is equal to ax squared plus q. People, where do we start? We can substitute, yes? 0 and 16. That's a x and a y, not so. So 16 is equal to a times 0 squared plus 16. What is 0 squared? 0 times 8, 0. That's supposed to have been a q, no? So q is equal to? So now my equation reads y is equal to ax squared plus 16. Now do we calculate a? You substitute another piece of information on this graph, which is negative 0. That's a x and a y. So 0 is equal to a times negative 4 squared plus 16. What's negative 4 squared? 16. So it's going to be 16a. Then over the equal signs, negative 16a is equal to 16. Divided by negative 16 both sides. So a is? What's my equation? Y is equal to negative x squared plus 16. Is there any confusion there? Yes?
What if you started, like you substituted, for choose answer, you substituted negative 4 and 0. You got the same answer.
Yeah, she's saying what if we had gone the other way around? It's gone the other way. She's going with, so she substituted negative 4 and 0 first. Remembering that's an x and a y. So 0 is equal to a times negative 4 squared plus q. So that is positive 4 squared, this is positive 16a take it over, so q is equal to negative 69. So these two unknowns becomes equation 1. Not so. Now you'll substitute the other point, which is 0 and 16, into the original function. Okay, because we can't use q and the negative 16a at this point. Okay. So we do that, we now get 16 is equal to a times 0 squared plus q. The q is 0, so q is equal to 16. So what do we do now? Since q is 16, we substitute 16 in here. So 16 is equal to negative 16a divided by negative 16. So a is equal to negative 1, which is the same equation I got earlier. Okay. Any other questions? Huh? So another example, on page 171. It will determine the values of a, k, and q if the equation of the graph sketched is y is equal to a times k to the x plus q. The horizontal asymptote is the line y is equal to 4. We can start here. Q is equal to negative 4, 2 to 4. Therefore, y is now equal to a times k to the x. Now what? We substitute any one of the 2 points, not so. I'm going to substitute 0 and 3. It's x and a y, not so. So I say 3 is equal to a times k to the 0 plus 4. What is k to the 0 equal to? 1. You get 4 over. The 3 minus 4 is negative 1. So a is negative 1, q is 4. Now what? Substitute into the equation. Y is equal to negative 1 times k to the x plus 4. Now what? I've used this. I've used that. Now I'm going to use this one here. So you're going to substitute 2 and 0. Remembering that's x and a y. So 0 is equal to negative 1 times k squared plus what do we do now? What do you do now? Take the 4 over. So negative 4 is equal to negative 1 times k squared. Now what? Divided by negative 1. So k squared is equal to 4. Square root. If I introduce square root, I must not forget. 5 is fine. But can k be negative here? No, it's always going to be positive. K must be greater than. So what's my equation? Therefore y is equal to negative 1 times 2 to the x plus. Okay, is there any confusion? Because yesterday we've done exactly the same. No? Yes, it's easy. Everything in maths is easy. Okay. So with that, you should be able to do exercise 8.4. Okay, let's stop the video at this point. Start the next one.